हेलो स्टूडेंट, गुड इवनिंग। आज इस क्लास में हम लोग यूनिफॉर्म सर्कुलर मोशन के प्रॉब्लम्स को देखेंगे। प्रीवियसली वी हैव डिस्कस्ड द काइनेमैटिक्स एंड डायनामिक्स पार्ट ऑफ यूनिफॉर्म सर्कुलर मोशन, and then let us see how to use the concept of those knowledge, kinematics part and dynamics part knowledge in solving the problems. Now once you take the HCVERMA book and if you solve objective 1, objective 2 and then you shift to exercise, then you'll find a very strong concept is developed regarding the subject. So first of all we'll see objective 1 of circular motion of HCVERMA book. There are 16 questions. If you go through objective 1, there are 16 questions in this, and every question is very nice and there is use of concept of the topic circular motion. So let us see how to solve these problems, and once you solve this you will have a strong concept and you'll feel confident of solving the problems of circular motion. After this you can shift to exercise. So mostly in my class we will be solving the problems of HCVERMA book. So let us see objective 1 of chapter circular motion of HCVERMA book. So we'll solve these problems, objective 1. Now let us take one by one. Objective 1 of circular motion of HCVERMA book. HCVERMA. Right. Let us take one by one. Now the first question we'll take. Question number 1. Let us see what it is and let us try to understand how to answer these questions. Now first question is, I will read the question. When a particle moves in a circle with uniform speed, right? Now what happens in uniform circular motion? The particle moves with uniform speed. Now 4 options are there and you have to find out which is correct option. The first option is velocity and acceleration are both constant. Now what is given in the question, that a particle is moving with constant speed. Let us take this CC, and a particle is moving with uniform speed. Now on this, a particle is speed with uniform speed. The speed is constant. Now the first option is velocity and acceleration both are constant. No, this is wrong. Why first is wrong? Because everywhere you will observe the velocity of the particle is changing and direction of acceleration is changing. This is A, this is V. You will observe everywhere in the circular path, if it's moved with constant speed, then the direction of velocity changes. The direction of acceleration is also changing. So first option is not correct. Second option is its velocity is constant. Velocity is not constant. So second option is also wrong. Its acceleration is constant but the velocity changes. Now velocity changes is correct, but acceleration is not constant. Why? Because everywhere the direction of acceleration, no doubt the magnitude of acceleration is constant, but the direction of acceleration is not constant. So direction is changing. Now that is C option is also not correct. Let us see D option. Its velocity and acceleration both changes. So you will observe everywhere acceleration and velocity is changing. So the D option is correct. What is the option? Its velocity and acceleration, its velocity and acceleration both changes, right? So this is correct option, right? Let us take second question. Now what is second question? 2 cars having masses m1 and m2 moves in a circles of radius r1 and r2 respectively. If they complete the circles in equal time, the ratio of their angular speeds omega 1 by omega 2 is given by. Now let us see what is this question. 2 cars having once m1 and m moves in circle radius r1, if they complete in equal time. Now in equal time, suppose question number 2, now it completes the circle in equal time. The time period t1 is given as 2 pi by omega 1 and time period t2 can be written as 2 pi by omega 2. So what is happening, if you see the ratio of time t1 by t2, you will observe omega 2 by omega 1. Now what is question? Question says that if they complete the circle in equal time, now it means t1 and t2 are equal. If t1 is equal to t2, what we observe? The ratio of omega 2 by omega 1 is 1. So what is correct answer? D is correct answer. Answer D is correct. D is correct answer, that is 1. Is it? Is it clear? Answer D is 1, that is correct. Now third question. What is third question? A car moves at constant speed on a road as shown in the figure. Now what is the figure given? Let us see question number 3. Question number 3 is, this is a circle of smaller radius, right? This is point A and this goes like this, and then this is B, right? So the circular track B is something having more radius, right? This R, B is more, and this is RA, the center of the circle. Here, this is center of the circle. Now, what is question? A car moves at constant speed on a road shown if R1 and R2 are respectively as shown. The normal forces by a car moves with constant speed. Now, a car is moving with constant speed. Is it clear? Now, we have the normal force by the road on the car is NA and NB. Then it is at a points A and B respectively. We have to find out the answer, the ratio of NA by NB. Now let us see, the normal reaction here is NA, right? And weight is acting in downward direction, mg. Now I can say here the centripetal force is, the net force towards the center is mg minus NA, that can be written as m v square by r. So I can say the normal reaction at A can be given as mg minus m v square by r, and similarly nb can be found. Now what we are observing, now you will observe here that if r is more, then what will happen? This will be less amount will be detected and this will be more. So if R is more, this will be less and this will be more. So if R is more, then N will be also more. So what we observe that since R is more here, so answer D is correct. What is answer D? Answer C is correct. Answer C is correct. NB is greater than NA. This is correct answer. Why? Because as R is more, this value will be less. Less is deducted, so more will be this value. So if R is more, this is more. If R is more, this reaction is more. R is less, this reaction is less. So correct answer is C. Now what is fourth one? A particle of mass m is observed from an inertial frame of reference and is found to move in a circle of radius r with uniform speed. The centrifugal force on it is given. Now centrifugal force is always observed when you are observing the motion, you are studying the motion of the object from non-inertial frame. Now if you are observing from inertial frame, then there is no need of centrifugal force, or centrifugal force will be zero acting on this. So what is the correct answer? The centrifugal force on it is mb square by r towards the center. That is wrong. Centripetal force is towards the center. mb square by r away from there. That is also wrong, because you are observing from inertial frame. अगर हम नॉन इनर्शियल फ्रेम से ऑब्जर्व करते तो mb square by r away from the center was correct answer. But since you are observing from
ground or inertial frame, so that is not correct. mb square by r along the tangent through this, that is also wrong. 0. The correct answer is D, that is 0. For question number 4, the correct answer is D, that is 0. Right? This is the correct answer. Why? Because in inertial frame, when you study the motion of circulating object, there is no centrifugal force acting on the object. But if you observe from the non-inertial frame that is rotating also with omega angular velocity, then we can say the centrifugal force is acting away from the center, that is m omega square r. So this is the thing. Now the fifth question is something like that. A particle of mass m rotates in a circle of radius a with a uniform speed omega. It is viewed from a frame. Now it is viewed from a frame which is also rotating, with angular speed omega 0. So obviously if it is, the frame is, the particle is rotating, this is question number 5, what it is. Now a particle is rotating about this axis with omega, and it is viewed from, let us take, viewed from a non-inertial frame, that is rotating one, that is rotated with omega. A man is standing here, he is observing the motion of this particle m. Now you will observe, when this man is observing, man is inside the non-inertial frame, what is acceleration of the frame? Omega square r. So the questions, the particle, the centrifugal force on the particle will be given as mass of the object and acceleration of the frame. So acceleration of the frame is omega square, omega 0 square r. Acceleration will be omega 0 square r. So we'll apply here a centrifugal force outward direction, that is m omega 0 square r. Is it clear? Is it clear? So that is the B is correct answer. The B is correct answer, that is m omega 0 square omega square a. Now you will observe, it is not m omega square. It is not m omega. We are not interested in the angular speed of the particle, but the angular speed of the frame from which you are observing is important, because that is non-inertial frame, and whenever pseudo force, centrifugal force is pseudo force, whenever a pseudo force is applied, that is also always equal to mass time acceleration of the frame. Acceleration of the frame is omega 0 square a, so that is why we are writing. Now rest of the part we'll see in the next class. Thank you. If you like the video, please subscribe the channel.